Okay, so we continue the lesson. We learned about logarithms a little bit last time, so let me review what we did. So, logarithm of a number a to the base b. So this is how we read it, okay? The logarithm of a to the base b. First of all, you need to know that this symbol in mathematics makes sense with three extra conditions. So I want you to remember those conditions. What are they? Yes, first of all, a should be positive. B should also be positive. But above that, I also have to have b not equal to 1. So even if I don't mention these conditions, when I write this symbol, I always mean that. So you read it as logarithm of a to the base b. And we had some definition for it. So when you say that logarithm of a to the b, you mean a number so that b raised to that number becomes a. That's the meaning of a logarithm. For example, when I say logarithm of 8 to the base 2, I am asking you, give me a number so that when 2 is raised to that number, the answer becomes 8. In this case, it is easy to realize that this is 3, because 2 to the power of 3 is 8. Okay? But sometimes, if I ask you the same question for logarithm of 9 to the base 2, it means the same thing, but I cannot calculate it on top of my head. If I ask you what is the meaning of this, you will tell me this is the number so that 2 raised to that number, it becomes 9. We know that there is one number with that property. What exactly that number is, I don't know. If I want to find an approximation for it, then I have to put this in the calculator and find an approximate number. But still, it doesn't mean that I don't understand what is going on. So it's not a complicated thing. It's just giving you an English sentence. This is the only number so that when I raise 2 to that number, the answer becomes 9. Yes? So that's the definition of logarithm. Logarithm of 9 to the power of 2. So you see, if I give you this equation, 2 to the x is equal to 9, if I ask you what this x is, the answer is what? The answer is logarithm of 9 in base 2. That's it. So if I ask you what is the logarithm of 9 to the base 2, you will tell me this is the solution to this equation. Yes? Is that understandable? Okay, so this is the meaning of the logarithm. So immediately you can answer this question to me, and that is a very, very important formula. So if I ask you b to the power of logarithm of a to the base b, what the answer is? What is this? Yeah, that's exactly a, because this is the number so that when you raise b to that number, the answer becomes a. And now you are raising b to that number. So the answer by definition should be a. And this is one of the most important formulas that you will have. Okay? So if a is positive and b is positive and b is not equal to 1, then what I can write b to the power of logarithm of a to the base b. The answer is simply a. So if you see b in the base of the power and in the base of the logarithm, these two numbers are the same, it doesn't matter. You just eliminate everything and simply answer a. Okay, so that is by definition. So let me call this one number 1. There are very simple things, so let me write here number 2. If b is positive and b is not equal to 1, if someone tells me what is logarithm of 1 to the base b, so you need to remember these formulas. So logarithm of 1 to any base, what is that? It is asking you, give me a number so that when b is raised to that number, the answer becomes 1. So what's the question mark? When you want to calculate a logarithm, you need to ask yourself, what is the number so that base raised to that number becomes 1? So what is the question mark? 0. Because b to 0 is 1. So the answer is this one. So remember this. Sometimes people say logarithm of 1 in any base is 0. So remember, logarithm of 1 is 0. So number 3. Logarithm of any number in its own base. If b is positive and b is not equal to 1, logarithm of b to the same base is what? It is asking you, give me a number so that when I raise the base to that power, it becomes the number in front of the logarithm. So what's that? No, b to power 0 is 1. Yes? 1. b to power 1 is b. So the logarithm of any number in its own base is equal to 1. So it doesn't matter. For example, if I ask you what is the logarithm of 5 to the base 5, what the answer is? That's 1. If I give you what is logarithm of square root of 2 to the base square root of 2, the answer is again 1. Because as soon as I see that these numbers are the same, the answer of the logarithm is 1. Yes? For example, what is logarithm of 10? 1. Why? Because we had a convention last time. Do you remember? I told you that if you don't see the number below, if you don't see the base is by convention 10. So logarithm of 10 is a short way of writing logarithm 10 to the base 10. And I just told you the logarithm of any number in its own base is 1. Yes? So I want you to remember, these are the rules that I want you to remember, especially the first one. These two in principle should be easy for you to understand. But that formula is also easy to understand, but it's better to have it in your memory. Yes? Okay. So now let me just give you some examples before going further. So for example, if I ask you to calculate 5 to the power of logarithm square root of 2 to the base 5, what is the answer? Yes, because you see this is exactly what is happening in the first formula. 5 is playing the role of these b's, and the square root of 2 is playing the role of that a. So based on that formula, the answer is what? Square root of 2. But let me make it a little bit better. For example, if I give you this, so I write 49 to the power of logarithm 8 to the base 7. So now what should I do? Of course, I am just solving those problems that you are not allowed to use a calculator, because if you're allowed to use a calculator, you put this number there, whatever it is. But now, how can I calculate this? I immediately see that if I am supposed to be able to solve this, this should be done by Formula 1. Because in Formula 2 and Formula 3, I do not have something similar to this combination. The one which is more similar to this is number 1. But in number 1, I cannot immediately use that. So, I cannot immediately use formula number 1. Why? Because in formula number 1, you need these numbers be the same. They are not the same. But if you think a little bit, it is not hard to realize that this can be viewed in a different way. So, do you have any ideas? For example, let me write something for 49. What should I write?
7.
Yeah, 7 to the power of 2 is a good idea. Still, I don't know why this is useful, but let us see. Instead of 49, I put 7 to this power of 2. And then, of course, on top of that, again, I have to write that power. So hopefully you agree with me this equality is valid. Yes? But then we know something from Math 1c that if I have a to the power of x again to power y, what can I write? I can write a to the power of x, y. Another thing, if I have a to power y to power x, what can I write? Again, a to power yx or xy. So it is a very important rule in logarithms to remember it in this way. Because both of them are equal to the same thing, it means that the left-hand side should also be equal. So it means a to the power of x to the power of y is the same as e to the power of y first and then to power x. So you can interchange the role of x and y if you want to. Should I do that here? Yes. It is useful here. Why? 7 is playing the role of a, 2 is playing the role of x, logarithm 8 to the base 7 is playing the role of y. So this is a to power x to power y, but we just learned I can write it the other way around. I can write it 7 to the power of y first, yes? And then to the power of y. Sorry. Is that right?
Yes.
So I interchange these two according to this rule. I want you to write something like this in your notebook. This is in this form, is not in the formula sheet. These are, but this in this form we need it. But now I hope that you understand that this is useful. Why? Because if I ask you, can I solve this part? Yes, that is exactly the formula. So what's the answer? What's the answer to this one? 8. But I have a power of 2 on top. So it becomes what? 64. Yes? So this is a better question. So yeah, I mean, I can design questions that you can solve it in that way. Okay, let us make it a little bit different. Yeah, some exercises that you can understand that formula a little bit better. This was the very standard simple one. This was a little bit harder, but now you understand it, so it is not hard anymore. But let me ask you about this. What do you think will be the answer to this problem? So 2 to the power of logarithm of, so let me write 2, and then I write 5 here. So let me write, so I don't want you to be confused with a lot of 2's. Okay, here. Without using the calculator, this is the question that I will ask you during the exam. Without using the calculator, find the exact value of this number. And if you don't mind, let me write it a little bit better for you. I need to put the base a little bit bigger. What was that? That was 3, yes? Okay. So we want to find the exact value of this. So what should I do? You have enough experience now, I think. You already know if the 3 was not there, you are done. What is the answer if the 3 were not there? 5. But unfortunately, now the 3 is there. So what should I do? So I cannot immediately use the formula. So yes?
2 to the power of 3 times 2 to the power of log 2 times.
No. So can you say again?
2 to the power of 3 times 2 to the log that one.
So did you invent a new rule?
No, because 3 and log 2, isn't it 3 times?
Yes, it is.
Exactly.
So this is a new rule that you are inventing. Yes. So it is like that. You are saying that a to power x multiplied by a to power y is a to power xy. Yes? Still you don't have any.
X plus y.
Yes. So that's not correct. So this formula, don't invent new formulas. Okay, so that's not working. Okay? But so what should I do? Yes?
Can you write 3 logs, like log 5 to the base 2, log 5 to the base 2?
Yes, this is one way. I don't want to do it, but I will follow yours because it works. Because he's saying that instead of when you say 3, so when I say 3x, it means what? it means one x, another x, another x added. Yes. So that is in that spirit you are saying that's what is you are saying is true, because 3 times of this log means log of 5 to the base 2 plus another log to the base 2 plus another log 5 to the base 2. Okay, I accept this one from you for the time being because that's completely true. Then
Another one.
yeah, so that formula was that x times y is what? X plus y is what? A to the power of x times a to power y. This we had in math 1c. Yes? So now I can do it like this. I can split it to what? 2 to the power of log of 5 to the base 2 multiplied by 2 log of 5 to the base 2. Yes, multiplied by 2 to the power of log of 5 to the base 2. Yes? Because of this formula. Because if I want to multiply powers, if the bases are the same, I write the same base and I add the exponents. I do it the other way around. It was already in this form. I split it into 3 parts. But now if I ask you what this number is,
5.
it's 5. What that number is, 5. The other one is also 5, so it is 125. Okay? It is good if you write this, that's completely okay, but it is not efficient. Why? Because I just ask you to do this now. Okay, do you want to write it 3,000 times? Okay, so you have to design a better way. So what's the better way? You can see it on the board, I mean. So let us go back to this problem. Instead of writing this, what can I do here? I just told you, you know, if you have a to power x times y, the formula is not a to power x times a to power y. Let me write and cross it over. That's not correct. But what is correct? We have 2 alternatives. I can write a to power x to power y, or if I want, I can write a to power y to power x. Yes? So, that is correct. This is the formula in Math 1c. This is also a formula in Math 1c. Okay, so can you tell me now what is useful? Logarithm of 5 to the base 2. I can write it in 2 different ways. I can write 2 to the power of 3 to the power of log of 5 to the base 2. I can also write it as 2 to the power of log of 5 to the base 2 to the power of 3. Both of them are true, but one of them is useful. Which one is useful? Yes, because if I use the first one, even though it is not wrong, but it is not useful because it becomes 8 to power log of 5 to the base 2. It is not wrong. This one is really equal to this one. But I cannot go further because these are not the same. So even though the first step is also correct, it is not useful. So I don't want to cross it over because it is not wrong, but it is not useful. So let me clean it. So the second one becomes now true and useful. Why this is useful? Because 2 to the power of log of 5 to the base 2, one can write what? 5. And then I have a power of 3 there. But 5 to the power of 3 is 125. So this one you can use for the case of 3000 as well. For example, if I ask you what is 2 to the power of 3000, logarithm of 5 to the base 2, what do? You write it as 2 to the power of logarithm of 5 to the base 2 and then to the power of 3000, yes? And then this part is 5, so the answer becomes 5 to the power of 3000. Okay? Of course, 5 to the power of 3000 is not a simple number, but it is better than having logarithm involved because our brain is not very well adapted to see logarithms. Of course, little by little you get used to it. But I prefer, which one do you prefer to work with? This combination or that combination? Of course, the second combination, yes? Because the second combination, at least it is more familiar to our brains because it doesn't have any logarithms involved. Yes, still it's a very big number, but this is not also, it is also a big number, but also an ugly number. But at least it is more beautiful, yes? Anyway, I hope now, let me ask you another question. let us see how many of you can solve this one. So I would write 7, and then I put 2 logarithms there. Logarithm of 3 to the base 7 plus logarithm. I intentionally write it smaller that you understand the whole expression is the power of 7. And then I would write 2 to the base 7. So what do you think I will do? I will be able to do. Solve this one now. Okay, so how should I do that? Any one of you. So what should I do? Lennon, you want to say something? A split. You can write it as 7 to the power of log of 3 to the base 7. And then 7 to the power of logarithm 2 to the base 7. Can you tell me what operation I put here? Times, multiplication. Yes. And now, can I answer this immediately? This is what? 3 multiplied. This is 2. The answer is 6. So these are the problems that you have to be very good at it. You don't need a calculator to find the exact value, and it's not complicated. Let me give you another example and wait for you. I want to combine a lot of things together in one problem. So I would, for example, write 11. Now 11 is a big number. Let me make it simpler. So let me write 3 to the power of 2 log of 2 to the base 3 minus 3 log, I would write 5 to the base 3. I hope that we can do this. If you need a little bit of calculator, calculator, you can use it. Yes, but in principle, you should be able to solve that. Okay, so I want to wait for you to solve this one. But be careful, this one is minus. I hope that you remember something from Math 1C. How this minus sign comes to the game? Do you remember something in powers? Division. So let me write this one as well on the board. So if I have a to the power of x divided by a to the power y, it becomes a to the power x minus y. These are extremely important formulas for this topic. So you see, if the whole combination is the exponent of 3. Anyway, so number 4. Formula number 4. It's at least it is on the board. So the solution to that problem, guys, it is here. Yes, you saw it. So number 4. If x is positive, and if y is positive, and if b is positive, and if b is not equal to 1, the formula is very interesting. Logarithm of x multiplied by y to the base b can be split into 2 logarithms, but there is an interesting property there. The property is not probably what you expect. The natural thing that you people might expect is this one. Yes? But the interesting property is this not product, it's addition. Okay? So if you have the logarithm of a product, it does not become the product of logarithms. The logarithm of the product becomes the sum of logarithms. So logarithm changes multiplication to addition. Okay? So this is an extremely important property of logarithms. I want to prove it for you why this is true. So extremely important formula. Why these conditions should be satisfied? Because it is clear. X appears in front of a log, so it should be positive. Y appears in front of a log, it should be positive. B appears for the base, so it should be not only positive, but not equal to 1. Yes? So this is an extremely important formula. Let us prove it. The proof of them are a little bit technical, but very easy. I want to convince you that this is indeed the case. I'm not deceiving you, okay? So the trick is this. I would say that let me take this number and call it an anything. Let me call it capital M. So I would say listen to me please, let this be M and logarithm of y to the base b be n. Yes? So I am calling this capital M to facilitate the way that I am working and call this one capital N. But now I want your help. Logarithm of x to the base b is being told to be m. What can I conclude from here? I want to get rid of the symbol of logarithm. So how can I write? What can I write in front of it? It means b, b, b to the m is x. That's the meaning. So b to the m is x. That's the meaning. Yes?
Can you write logarithm of b to the xy is equal to mn?
No. I am saying that this m is not there in my formula at all.
Okay.
I myself say that because I am lazy, let us say, to write so many things, I call it m. When I say m, I mean this. Yes? And I am calling the other one n. Yes? Is that okay? So, but if I call this m, then it means b to power m becomes x. Yes? And when I call the other one n, what is the logical consequence of it? It means what?
b to the power of
B to the n is what?
y.
Is y. Now, let me multiply them side by side. If this one is equal to that and this one is equal to this, it is clear that multiplication between these two will be the same as multiplication between these two. Yes? So it means that b to power m multiplied by b to power n is equal to x times y. But in Math 1C, we learned something about this. What can I write? I can write b, but I have to add m and n. So it becomes m plus n is equal to x times y. You agree?
Yes.
Okay, now can you tell me what is m plus n?
Log y.
Yes, because I told you that. You remember the motivation? The motivation of talking about logarithms was that my unknown is in the exponent. So if let me write it here again. B to the power of m plus n is xy. If I insist you to write this in logarithmic form, this is in exponent form, exponential form. I want you to write that in logarithmic form. What do you write? You need to reverse engineer. Write a logarithm so that the answer becomes that. So what should I write? Log of, so you need to fill up these gaps for me. Fill it up in a way that it gives back this to me. So we are doing the reverse engineering part, yes? This is important for the proof. Okay, so can you tell me, Omar, what should I put here?
X and y.
X and y. What should I put here?
B.
B. What should I put here?
Plus.
Do you agree? So if you don't believe, go backward. How do you go backward? This to this power is equal to this. Yes? So we did it in a, I mean, you should be, it's not hard. You need to understand how to do it in a way that when you go backward, it becomes this. Do you agree that I can write this? Okay, but now, if you don't mind, let me take off these circles. We don't have circles here. Yes? This is what I got. One more step, I am done. I copy and paste the left-hand side. But on the right-hand side, what is m? M is the name I gave to this guy. And n is the name I gave to this guy. So instead of m, I put its name. I mean, that was the name for xb. Logarithm of xb is m. So I take m off and put that expression in, and then I see a plus. I take n off and put the other one, which becomes, and that is exactly what we wanted to prove.
Bravo.
Yes? Thank you. So, anyway, the proof is important for the people who want to understand why these formulas are correct. But what I want you to learn for the exam is, of course, proof is good, but you need to be able to use it. Okay? For example, can you tell me why this is true? Uh, So if you see this equality, of course you can use your calculator and see that these numbers are equal. You calculate logarithm of 12 to the base 2. You put it aside, you calculate the right hand side, and then compare them, they are equal or not. But let us say that I do not have any calculators available. But I know this formula either in my memory or in the formula sheet or here on the table, on the board. So why do you think this is correct? Okay, so how should I do that? A hint. Write 12 as a product. Yes? 6 times 2 is correct, but it gives something else, which is not wrong, but this is not what we want. Let me test your understanding, test your idea. So you said that let us write what? It's not bad, by the way. Let us follow yours. So you're saying that logarithm of 12 to the base 2 is what? Logarithm, instead of 12, you write 2 times 6 to the base 2. Yes? That is not wrong. Definitely correct. Can I use this formula now? It's a product. Logarithm of a product becomes the sum of logarithms, not the product of logarithms. So it becomes the logarithm of the first one to the same base plus the logarithm of what? Second one to the same base. Yes? But this is a previous problem. I hope that you don't forget. What is logarithm of a number in its own base? 1. It's still on the board. Number 3. Yes? So this is 1. It becomes 1, and then it becomes plus logarithm of 6 to the base 2. So what you proved logarithm of 12 to the base 2 is 1 plus logarithm of 6 to the base 2, which is not wrong, but that is not what problem wants, unless you find a way to continue, or you change your strategy from the beginning. I mean, you can continue, because if you continue, it will work. So what do you think I will do now?
Rewrite that 6.
Again. As what? 2 times 3. Okay, so let us follow yours. So that worked. You see, this is a good point about mathematics. If you do it correctly, it will work. Of course, if you do it correctly, sometimes it doesn't work, because you see, you have to find not only the legal way, but also a useful way. But in this case, it is useful, because I will continue now. I will write 1 here, plus. Instead of 6, I write what? 2 times 3 to the base 2. And I write this as 1 plus. I would write logarithm of 2 to the base 2 plus, again, logarithm of 3 to the base 2. Yes? But now, what is logarithm of 2 to the base 2 again? So 1 plus 1, this 1 is here, this is also 1, and then I have to write this as well. So what happens now? 1 plus 1 is 2 plus logarithm of 3 to the base 2. That's correct. So without calculator, I was able to confirm that these two numbers are exactly the same. But what is the best way? Because this formula, I wrote it for 2 numbers. This is also correct for 3 numbers, 4 numbers, 5 numbers, yes?
You can divide 12 into 2 multiplied by 3 multiplied by 2.
2
Then you can divide that up.
into 3 parts.
Yes, and then
Yes.
you can cross
Yes.
over one of them.
So logarithm, this, if you write this, that's 100% correct. But if I want to write it a little bit shorter, instead of splitting 12 to 2 parts, I split it into 3 parts by 2 times 2 times 3 to the base 2. And now I can split it in one stroke. So it becomes logarithm of 2 to the base 2 plus logarithm of 2 to the base 2 plus logarithm of 3 to the base 2. Yes? Okay. But this one is 1. This one is 1. So it becomes 2 plus logarithm of 3 to the base 2. Yes? Okay. It is up to you which one you prefer. But I mean, it is better to write it in one stroke. Okay? Now test your understanding again by a simple question. What do you think is the exact value of this number? Logarithm, I don't write the base, you know what does it mean? Logarithm of 2 plus logarithm of 5. What is the exact value of this? When I don't write the base again, what is the base? The base is 10. Logarithm of 2 is an irrational number. I mean, the decimal places go forever. The same is true for logarithm of 5. But it is interesting that if you add these two numbers, it becomes one exact number.
1.
1. Why?
Because you multiply 2.
Yes, because now I am going the other way around. I told you in mathematics, when you write a formula, be ready to go both ways. Sometimes this is given, you need to write this like this problem. Sometimes this is given, you want to go back. So you should be able to read it back and forth. So logarithm of the product is the sum of logarithms. But the sum of logarithms is also logarithm of the product. So here I have the logarithm of the sum. Sorry, I have the sum of the logarithms. What can I write? I can write logarithm. So you see, I have to multiply 2 and 5. Understandable this part?
Yes.
So, but log 2 times 5, everyone hopefully knows it is 10. But the base is not written, is also 10. So I have logarithm of a number in its own base. Logarithm of any number in its own base is 1. So logarithm 2 plus logarithm 5 is exactly equal to 1. So it means that those infinitely many decimal places, they add up in a way that miraculously it becomes 1 at the end. Okay? Any questions so far? Okay, let me test your understanding before writing the formula. What do you think will happen? What is an immediate consequence? Do you think this formula on the board is also useful for such a scenario? Let me write something for you here. Logarithm of x to power 2 base b. Do you think that this formula is somehow useful for this construction as well?
Yes. Because
Why?
x squared is x
Multiplied by x. Let us investigate what's going to happen. So, you write x squared as x times x. But let us see what can I write. Help me. What should I write? Yes?
Log x over b
Not over. To the base b
to the plus log
plus log of.
x to the b.
But can I go further?
You can, I don't know, maybe.
Now you can. I mean, it's not hard. A box plus another box.
2.
2 boxes. Yes? Let me close this. Okay, so it becomes what? 2 log. Yes. So now let us see, let us discover something else. You immediately realize a pattern. Let me make it to the power of 3. What happens now? Is this formula useful for this one as well? Yes. I can write it how many times? 3 times x to the base b. And then what happens?
3 log
It
x.
becomes 3 log, because it becomes log of the first one plus log of the second one plus log of the third one. And then how many boxes now I have? 3 boxes. So it becomes 3 log. Yes? I hope that you agree with me. In a similar way, I can write something very nice. X to power n b. What do you think will be the answer to this? Yes?
It will be n log
N times, which I don't write times, n times logarithm of
x.
x to the base b. So it's a nice property. If I see a power here, if I want to, I can move this power to the back of the log. And the other way around. So if you see a power, an exponent there, this exponent goes back to the log. And if you see a number behind the log, if you want to get rid of it, there is one way. Move it up to x. Is that right? Okay. But what type of number? My proof, my idea of proof is based on not every number. What type of number it works for this kind of proof?
When it's positive?
No. Yeah, yes, but more than positive.
When it's not negative.
Okay, but no, I mean, so for example, because when I wrote x to power 3, I wrote multiplication of x by itself 3 times. Yes? If I write x to the power of 4, I will follow the same rule, but I have to write it 4 times. But not all powers can be done in that way. For example, if I write x to power 1/2, do you still believe that I can move 1/2 to the back or not? Which is a still open question. But of course, you need to know that because I proved something for 3, 4, 5, 6, it doesn't mean that I have to take it for granted that it also works for 1/2, 2/5. You know, they are not like that. For example, I want you to understand the question because these are also mathematically important questions. Okay, so now my question is this. If I ask you the same question here, x to the power of 1/2, and I put b here, it would be very nice if I still can move it to the other side. Yes? But so this is why I put a big question mark. First of all, I want you to feel that there is a question mark. Do you feel it or not? Yes? Okay. So do you feel that there is a question mark or not? Because
Yes.
you told for me what to do with x2, you told me what to do with x3. I hope that you agreed that I can continue this process for x to power 4, for x to power 5. This is more or less trivial. But it is not at all trivial that logarithm of x to the power of 1/2 can be moved to the back. Do you understand that? Because I cannot write x to power 1/2 means x times x 1/2 times. It doesn't make sense. So that's important to understand mathematically. Because I was able to find a formula for this particular type of powers, integer powers, there is no reason that I believe that the same idea will work for fraction powers. Because the definition of a fraction power is completely different from a definition of a natural power. But what is your idea? Do you think it's true or false? We have to explore. And then if we explore and the exploration is finished, if it is true, we set it up as a formula. Otherwise, we say that no, it is only working for integer powers. Yes? Let us see what we can do.
Can you make it x to the minus 2? Or
No, if we still no, I want to make the same thing. I want first ask this question. Here, this power, I was able to move it to the back. My question is that this is also a power. Do you think I can still move it to the back? Of course, here you have to make sure that x is positive. Otherwise, x to the power of 1/2 is not defined. Yes? Okay, can you find a trick to show me, yes, this is also true. But you have to be smarter and more creative. Do you have any idea what to do? You have to be more creative here. You still want to have a product. Yes? X to power 2 was x times 1. But you already know that x to power 1 half. I am in trouble. How can I write it as a product? I can write, but the powers become again fractional. It's not useful. Change your perspective. Try to think outside the box. So what can I do? Look here, not here. Here, when I wanted to prove, for example, Nicole started from this side and we went together to the other side. Yes? But my point is now, could I start it from this side and go back to here? Why? Because 3 log can be written as log 3 times. Then I have the sum. I can combine it with product. Then I can go back here. So it was easy to go back and forth in both directions here. But in this direction for this fraction power, I don't know what to do. But still I can go the other direction. Can you help me to write that? So here, my advice to you is to write from the right hand side. And I will write the 1 half here for you, but I write also the log here for you. But I am waiting for you to fill up here in a way that it becomes useful for the purpose of solving this problem. You know that this is x, but if I write x, there is no progress. I have to do something. Yes? Yes?
Is it x divided itself?
No, x divided by itself is 1. X to power 2 is not x. I cannot change the problem unless you compensate for that.
What about x times 1 half?
No, x times 1 half is what? X times 1 half means x over 1 over times that. It means x times 1, 1 times 2. So x times 1 half is x over 2, not x to the power of 1 over 2.
What is?
I want you to write something that is on the one hand equal to x. On the other hand, it is useful to solve my new problem. Yes?
X to the power or 1 half to, times x to the power 1 half.
Thank you. So I would write it as x to the power of 1 half times x to the power of 1 half. Yes? Because x to power 1 half times x to power 1 half. I hope that you agree with me. On the one hand, it is back to x.
Yes.
Yes? On the other hand, it is a product. So we just learned that if I have a log for a product, what can I do? I can write the log of the first one plus the log of the second one. But there is a 1 half there, so don't get confused. I copy and paste that 1 half. I open a pair of brackets, and I use the formula. Log of any product, including this product, is equal to the log of the first one plus the log of the second one, which in this case coincidentally is the same as the first one. Yes? Okay? Now, what can I write for this one?
Log x.
No, what can I write for this one?
2 log.
So I have to kill myself.
You can put like a
Oh,
2.
is 1
Box plus box. I don't know, is this box plus box so hard for you?
1 half log.
This is now the box. This is also the box. So what is that? 2 box. How many times you need to forget about this? Okay, so I have 1 over 2 multiplied by, instead of writing box plus box, I write 2 boxes. Yes or no? But then what do you see? These 2 and that 2 are cancelled. What is left for me is a log of x to power 1 over 2 over to the base b. But what is this guy? This is the left hand side. So what did I do? I started from the right hand side. Doop, doop, doop. I reached to the left hand side. Yes? So it means that they are equal. Okay. So now we are happy. I don't want to discuss about this more, you should be able to convince yourself that this formula not only works for these kinds of powers, but for the good news is that it works for all kinds of powers. And then I want to formulate it as number 5 here. So if you don't mind, let me clean this. So let me clean this and I will do this. Number 5, I would say that I want to write something like this. X to power, if you don't mind, let me call p, because when I write n in mathematics, usually we think that n is an integer. So let me use p. And then I put a b here, but I need to write my conditions. P is any real number. This symbol, don't freak out. So p, this symbol means belongs to. R is the set of real numbers. So when I say p belongs to real numbers, it is a shorthand way of saying p is a real number. Okay? So p belongs to R. B appears in the base, so it should satisfy the condition that b should be positive and should not be equal to 1. And what? Because I want to move p to the other side, then x appears in front of a log, so x should also be positive. I want you to pay attention to these conditions. Every formula is valid in its domain of applicability. When I have a formula, I cannot say the formula is always correct. For example, if I write logarithm of 1 over, so base 5, you know the answer to this. Logarithm of 5 to base 1 to base 5 is what? 0. But I can write, instead of 1, I can write minus 1 times minus 1. Do you agree?
Yes.
Yes, but then I can say that I have a product. I write the log of minus 1 to the base 5, log of minus 1 to the base 5. Yes? Then you see that I am in trouble. I just want you to understand, you are not allowed to use this formula for any choice of x, y, and b. You see, these conditions tells you when you are allowed to use this. So if you see this, and for example, a multiple choice question, I say, for example, which one of the following statements is true, and I write this for you. It seems that I am using this formula, but that formula does not work for this case. Why? Because this number is negative. So be careful. Usually students doesn't care about these conditions, but that is extremely important. Every formula does not claim that I am true always. There is some limitations for every formula, but sometimes formulas does not have limitations. For example, a plus b to power 2 we learned, a squared plus 2ab plus b squared. This formula does not have any limitations. It means whatever you choose for a, whatever you choose for b, if they are real numbers, that is working. But this formula doesn't tell you that I work for every choice of x and y and b. You have to respect these, and then I produce you a correct statement. Be careful. Okay, so that's an extremely important formula to understand, yes? If I have log of x to some power, whatever that power is, doesn't matter. If you want to, what can you do? You can take this and bring it back. What is the operation between them? The operation is multiplication that we usually don't write. Okay, but don't learn it only in this way. Sometimes the number is behind. You want to get rid of it. The easy way to get rid of it is just to erase it, which unfortunately is not valid. It's not legal in the world of mathematics. So you need to find a way to get rid of this interloper, yes? So what do? You just bring it up. That's the only way. So do you remember? Now I go back to this problem that we solved. Now you can use this formula to solve. For example, I don't remember exactly the numbers. No, this is not on the board. Let me just write it myself. So I write 2, 3, log. I think that was the example. Do you remember we solved this problem?
Yes.
Just before this formulas. Do you remember what I did?
Yeah.
So we did it like this. 2 log of 5 to the base 2 and then to the power of 3. This is the way we did it. And then I told that what is the answer to this? 5. So it becomes 5 to the power of 3 is 125. Now can you tell me a second way by this formula now? So 2, 3 log of 5 to the base 2. So what can I do now? Yes?
Move the 3 to
Yes. This is my, I don't know, do you know the English word interloper?
Yeah.
Yeah, interloper means a person that you really don't want that person to be there, but it is there. Yes? I don't know how to translate it anymore. So, but this 3 is like that. You don't want to have that 3, because if the 3 is not there, you know what to do. But unfortunately, the 3 is there. So what can you do?
move it.
Yes, you move it up. So it becomes 2 to the log of 5. 3 goes up there, and then this is 2. And now what happens? This number and that number is the same. So what is the answer? It's 5 to the power of 3 is 125. So this is now a new way of doing the same problem. Yes? We couldn't do it in this way because we didn't know about this formula back then. Yes or no? Okay. This formula that I want to write is not in the book, but I want to take it as an exercise. I want to see how can you discover this. It's a harder question, of course. I mean, because if you are a mathematician, you try to make a new game for you because you know life becomes boring, so you need to find a way to be living fine. So I have a log. I learned that if I have a power up there, what can I do? I can bring it back. This we learn now. Yes? Now, do you have any questions or curiosity now? Okay, so if you don't have any curiosity, yeah, so what can... But I have a curiosity.
How can you move B?
No, B cannot be moved because B is one part of the definition of the logarithm. So I cannot just throw it out, yes? We can do something like that about it. But my curiosity is that if the power is not here, is there, can I do something like, can I say something about it? So my question is that logarithm of x here, x is left alone, but this b is now raised to power p. I don't know. This is just a question. I want you to understand. If you are a good mathematician, you should start asking a lot of questions from yourself and try to solve them. That's the way what they do. Yes, they design problems for themselves and then sit down and solve it. And and that is a little bit because it's a crazy world. They are being paid for it. You know. So they make a question, solve it, and then get paid. That's good. But because of course mathematics is really, really helpful, you know. At least you can see in ChatGPT. By the way, the mathematics behind ChatGPT is not very hard mathematics. It's extremely simple. This is the mathematics we knew actually nearly 200 years. But they have modified this in a way that it can be used this. So don't think that the mathematics behind ChatGPT, if you think that there is a difference between mathematics and ChatGPT, you are totally wrong. Yes? How ChatGPT can talk to you is based on mathematics. Yes? Okay. So mathematics is useful, at least. It doesn't mean that you should like it, but I want you to understand it is useful. Yes? Yeah. So the spell check on your computer is mathematics. Yes? The spell checking. Even the font, when you make the font bolder, if you make the font italic, it's a mathematical transformation. Yes? So you are using it every time, every day. So, yes. You can go, yes, you can go and see how people can design fonts. Of course, artists are also involved because they want to design beautiful fonts. So they draw them, but if you want to go from one font to the other font, if you write my name, I don't know, using New Times Roman, and then I want to change it to, I don't know, what is this, Comic Sans Serif or something? A transformation, a mathematical function is changing that to a new one. Yes. Okay, now let us go back to this question. I hope that I agree that mathematics is useful. I hope that you like it. But if you don't like it, I really that much. Yeah, but you have to do it because this is your course. Now my question is that, do you have any idea what can I do with that p? Now the interloper is that p. Yes. Do you have any ideas?
Well, if you do that to the power of BP, you can just put B beside log.
Can you repeat?
If you do B to the power of P to the power of log X over BP.
So this one.
Yes, to the power of
Yes.
B.
Yes.
You can just put P beside the log.
this one goes here.
Yes.
Okay. But then I want you to see what can I do. Okay, so what you have said to me is completely right. But do you believe that is a good formula? Yes, of course. I mean, if you write this, that is not wrong. But my question is not that how is this, what you have said is true, 100%, okay?
Yes.
But how this true statement helps me to say something about that? Yes? Let's think. Yes, that is a good thing. Yes. People have forgotten to think these days. I was thinking that your idea might help, but I don't find a way to see how it will help.
That equals to x and x. Maybe you can.
Okay, think a little bit. Important in research, Hasbulat has this idea. You shouldn't follow him unless his method is very close to solve the problem. Because you know that in research, the problem could be so hard that you cannot solve it, but you can have good ideas. Still, you cannot solve the problem with your ideas, but other people look at your ideas from different angles and they say, no, Hasbulat has this idea, couldn't find a way out, I will find a way out from his ideas. This is one way. Another way is you just totally think about a different way, completely. Don't be in this trap. If you think there is a way to go out from here, just do it, follow his, and then that would be a collaboration, that would be a teamwork. So if you do that, probably you should write the name of both of you on the article, or you have to refer to his article. Yes, something like that. I'm trying to use this as an analogy to understand what's going on.
Maybe.
Yes. Me hint.
Yes.
Yes, I can. So I would say that, you see, this is important even in the world of mathematics, even though you have to be creative, but reading the work of the previous people is very important. For example, in case, do you remember how I proved this? Okay. But at least you are honest. I like honesty, yes. Okay, anyway. So that's what I'm saying. If you don't have a good memory, I mean, of course, if you work in a field every day and every night, you will actually improve your memory on that. But do you remember I gave names to them? Yes? For example, I would say that, give it a name. Let us say this is n. Okay? So you see, let us say that I come to the field new. I read the work of other people. I see how they prove the problem. I got the ideas. I remember the ideas. Then I have a problem more or less in the same field. The first thing comes to mind, let us use the idea that another person used to solve a similar problem. This is the attitude. It might work, and of course, it worked. It might not work, so then I have to be smarter to find a different way. But what do you think I will do now? I mean, do you think that's useful?
Maybe.
Okay, let me ask you one question. You want to find, so here, if I ask you what I did, you will tell me like this. You will tell me, Babak, you find the connection between this logarithm and this logarithm. Yes? This is what I did. I found the connection between this log and that log. Now, if I call this n, what do you think I will call n?
BP.
No, not BP. Because again, what is your goal? If you don't know the goal, then it would be hard to continue. My goal here was to find a relation between this logarithm with this extra p with the plain logarithm without the p. I found the connection between them. So in this case, if I want to name them m and n, I will call one of them m and the other one n, and try to discover the connection between m and n. Yes? So if I want to do something similar to this problem, I want to know the connection between m and what as n? Yes?
Is it that
This one. Yes, because I want to see how they are connected. Yes? I want to know how this logarithm
you forgot the p?
connects. No, there's no forgetting. I want to know how this logarithm with p is connected to this logarithm without p. That is my goal. What I'm looking then. That is my goal. I want to see how these two logarithms are connected. Yes or no?
Yes.
Okay. But then it is easy now. I wouldn't say it is hard. Okay, because we don't have time, let us continue. We'll finish it. So tell me, from here, what can I conclude? No, tell me first this one. This is very easy. What can I conclude? Logarithm of x to the base b is called n. What can I conclude?
B to the power of
B to the n is x. Yes? What can I write similar for something similar for this one? B to the power of p to the power of m is x. Yes or no?
Yes.
Okay. But there is a formula in Math 1c which is b to the power of p times m is what?
Yes.
Is x. And then b to the n is x, b to the pm is also x. What is the logical consequence of this comparison? They are equal. So b to the power of bpm is equal to b to the power of bn. Okay? What is the logical consequence now? B to something is equal to b to something else. This equality cannot hold unless...
something is something.
Okay, very good.
No, because he says B.
Something is equal to something. Yes, thank you. So, because b to something is equal to b, you compare them. They are supposed to be equal. On the one hand, the bases are the same. I insist to make them equal. There is only one way to put them equal, unless they are not equal, unless the powers are the same. You know or not? Yes? But now, do you agree with me that m is 1 over p times n? Yes or no? I divided everything by p. Yes or no?
Yes.
Okay. But this is finished. Can you see why? Can you see why it's finished? Because what is m now? Tell me, what is m? M is logarithm of x b to the power of p is equal to what? 1 over p logarithm of what? X to the base b. Do you agree or not?
Yeah.
So we discovered the formula. It's a very nice relation. You couldn't anticipate that. If the power is up there, it goes directly to the back. But if the power is there, it doesn't go directly to the back. It becomes reversed and goes to the back. Yes? Is that understandable? So you see, this p does not appear as p. Appears as 1 over p. Yes or no?
Yeah.
Yes.
Okay. So this is another formula I will add to my list. What was the number? Do you remember? 4, 5. I will call it 6. No, let me call it 5 prime. Because this is not in your book. Okay? It is 5, similar to 5, but it's not in the book. I want you to remember, it's a good formula. If you have power on the base, it does not go directly to the back. You have to find the reciprocal, that number is called reciprocal, and then move it to the back. So for example, if I say logarithm of 5 to the power of 8, do you agree I can write 1/3 logarithm of 5 to the base 2?
Yes.
Yes.
Why? Because 8 is 2 to power 3. 3 does not go there. 1 over 3 goes there. So this formula is valid. Yes? Okay. So this formula is not in the book, but I think that for the people who are interested to know mathematics a little bit more, this is also a good and nice formula. Any questions? Okay.